results. It's moving 7.8 millimeters. 7.8 millimeters. This is what, 250 millimeters, right? So. And now if I look at it, this is how much it's moving. Not much, okay? Very little. So 7.8 millimeters, that's like about what, a quarter of an inch? Roughly. Not moving very much. Alright. Any question on this problem? Alright, so now we're going to go ahead and homework 2 is up. I have 300 newtons going into the cage. I have 1,000 newtons in the vertical direction. So this corner over here of the ladder, it's restrained from moving in and out of the page. So all the other degrees of freedom are free. The only one that is constrained is the one coming in and out of the page. So these are the cross sections. So this is the cross section of the tubing that goes across. And then this, of course, right here is this bar right here, the vertical member. All right, so if I draw that, I'm going to draw my stick model. The thing I noticed right here is I can't just, it's easy for me to draw a line and then come into the line and draw these horizontal members, right? But if we do that and I go to mesh it, when I click on the line, it's going to try to do the whole line. Where the horizontal circular members meet the C channel, there's not going to be a node there. I have no way of putting a node there very easily. So when I draw this, it's important that those vertical members, I need to draw that using 1, 2, 3, 4 lines. That guarantees that when the horizontal members come across, there's a node right there. So I must have a point where the horizontal and vertical members meet. I need to have a point right there. The only way I'm going to get a point right there is that I draw separate lines. Now the other thing we notice that we have a force, and this horizontal member right there, we have the 300 and 1,000 newtons being applied at that point, right? Somehow I need to get a point there. I want to apply a force on a point there, right? So how do I put a point there? 2 lines. 2 lines? Yeah, I don't like it.
You could put like
I'll use 1.
odd number of units, right?
Odd number of elements.
Elements.
Odd number or even number? If I put 2 elements there, right? I have an element and an element using that horizontal member, right? Do I have a node at the center? Yes. If I use 3 elements, do I have a node at the center? No. So I need to have an even number of elements along the horizontal. As long as I have an even number of elements, I'm good. How do I check to make sure that it is at the center? Now, I'm assuming that when I tell it I want an even number of elements, it's going to make sure that I have a point in the center. But how do I check that?
Measure it.
Just to make sure. Measure. I'm just going to measure between those 2 nodes. And as long as I measure and the measurement comes up to what I want, 150 millimeters, I'm good to go. Alright, so let's say I'm going to go ahead and draw this. I tell it materials aluminum 2014, dimensions are millimeters. Here's the cross section. These are pinned, right? So it's free to rotate on the axis coming out of the plane. The other ones are fixed. And of course it's fixed in X, Y, and Z. Alright, so I'm going to go ahead and draw this. And something, we created the FEM and SIM. I just open the SIM and it'll open up everything. Alright, so this is what I drew. This right here is just one of the horizontal members. So I'm just drew one of those. I'm going to work with that. So I'm going to go ahead and start advanced simulation. I'm going to come over here, right click, do FEM and simulation. Geometry options. Since I have lines, I need to tell it to take lines into my FEM. This create idleized part. We don't usually do that. NAS, trans, structural, okay. And then the next screen is this right here. We hardly ever change that, so it's okay. Alright, so I've got that going. So here's my FEM model. I'm going to go ahead and mesh it. When I need to mesh it, the first thing I need to do is create collectors. I'm going to click over here. I'm going to do my mesh collector. So I'm going to do 1D, bar collector. Actually, I want beam, right? This is to do everything in beam, all dimensions. What? No, I don't. Technically, how should I go? When do I use beam elements? When my cross section is not symmetric. So I have a C channel, or when I have something that's open. So here I have a C channel, it's open, I don't have a uniform cross section, a symmetrical cross section. So I'm about all 3 axes, or 2 axes. So I want to use beam, so I'm going to use beam elements for this C channel. I'm going to go ahead and use bar elements for this. So I'm going to come in, beam elements. I'm going to click right here, break physical. I'm going to come over here, beam. I'm going to do my cross section. I'm going to do my C channel. And then I come over here and I look at my dimensions. There's 60. Wait a minute, dimension 1 is 30. So I'm going to do 30. I'm going to do 60. And then these are both going to be 5. And then I can do my preview. This is what it looks like. Alright, so this right here, this little tick mark right here, represents the center mass. That's my center of mass, right? So that's the center of the part. This XY, I'm sorry, this YZ, that's going to be my shear center. So we'll discuss shear center on Wednesday. Okay, for now, just that's my shear center, that's my neutral axis. Now, different finite element packages do it different. So NX, probably most in ASTRAN, likes to use the shear center. You'll see why on Wednesday. Okay? Now, when we draw our model, it's just a stick model, right? So where do I want the beam to be centered along that line? Normally, we put it on the neutral axis. So that little blue mark, tick mark, I want that to be on the line that represents my beam. Okay? So I want that little tick mark to be on the line that represents my beam. Alright, so cross section looks good. I'm going to go ahead and close this. I hit OK. And there's the channel. I can go ahead and get the little wrench if I need to change something. Alright, so now I can go ahead and create the other one. And this one's going to be circular, so I'll go to 2.
The outside dimension is gonna be, and this is gonna be radius, right? So that's gonna be 15. And this other dimension is gonna be 13. I could do a preview. And that's what it's gonna look like. Now in this case, the shear center and neutral axis are the same. Alright, so I go ahead and close this. Round. Alright, so I have my two cross sections defined. I go ahead and close this, so I want this to be, I'm doing the beam, so that's going to be C cross section. I'm going to go ahead and pick my material, 2014. So there it is, I hit OK. And now it comes up. Alright, so there's that one. If I come over here and click on this, then we can see the C channel right there. I can go ahead and come back up over here. I can do the same thing now, but now I'm going to come over here. I'm going to do my bar collector. I'm going to go ahead and click here. And now I can click my circular section, 2014. Okay, and actually this was already written. I hit OK. And then over here I might be, alright, so now I see the two right here. So I'm going to come over here. I'm going to mesh this kind of funky just for the fun of it. So I'm ready to mesh now, right? First thing I do is I go in, I do my mesh collector, I create my different cross sections, I have all of those created now. So now I can go ahead and do this. I'm going to do C beam. I'm going to go ahead and do this based off of size. So that's the dimension. So I'm going to come over here, I'm going to go 25 millimeter. I want to merge nodes, right? So I want to tell it to merge node. I always shut this off. Alright, so I'm going to go ahead and do my beam. That's going to be the C channel. I'm going to go ahead and click on this one. And then I hit apply. And then I'm going to come over here and click on this one. I'm going to hit apply. And then I'm going to go and click this to bar, size, merge, tube. And then I'm going to go ahead and hit OK. So it's all meshed up. Here's the two from my C channel, so there's one, there's the other one, and there's my two. This one's pretty simple. I could have selected the whole line. I'm going to right click on this. I'm going to go edit display. Actually, I'm going to hit cancel there. I'm going to do it on my collector. I'll do all of this. Edit display. Solid. Go ahead and make this, that's good. And then I'm going to come over here. That's good. Alright, so that's fine. So this is messing up, right? It's not uncommon for the graph NX. It's something with NX. It doesn't matter what kind of graphics card, it always does this. To get this to go away, all you need to do is right click, go to orient view, do isometric, and now it's all gone and everything. Alright, so we said right here that the center and neutral axis were the same for the tube, right? So this line, that's the line I drew to represent my model, that the tube is going down that line like we wanted to, right? The C channel, we want the line to be going along the neutral axis. Is it going along the neutral axis? Oh, that was the right view. like, man, that don't look good at all. So we're looking down the tube, right? So my neutral axis is kind of over here, so I want that over here at this point, right? Same thing with this one over here. The problem is these are oriented in the wrong direction, right? That's the problem. Somehow we need to fix that. So that's what I'm going to show you how to do. Alright, so the first thing is, let's get these oriented the right way. If this is how it looks, which one's oriented the right way? The top or the bottom one? The top one, right? It's not placed correctly, but it's oriented the correct way, and that this open part should be facing towards the inside, right? Alright, so let me double check. I want to orient right view. Alright, so this is okay, this is not oriented in the right direction. Alright, so this is one of the reasons why we create, if I created all that line at once, there's no guarantee that it's going to be facing correctly. So when I do it, I always do it each line separately. That way I have full control over each line to orient it any way I want. Alright, so I'm going to come over here. I need to take this one and rotate it so that it's facing the same direction as this. So I click there, it's that one, right? That's the top one, that's the bottom one. So I'm going to right click on this. And I'm going to come down here to edit mesh associated data. I'm going to click on mesh associated data. There it comes up with this. And now I'm going to scoot this to the side. And now I'm going to come in here and zoom in. So remember when we kind of went over 1D elements and it showed the X and Y kind of axis along the cross section? So if I look, so this little Y and Z that you see here, that's like the local coordinate system. Okay? That controls the orientation of the cross section. So now I'm going to come over here. And how do I want that to face? I want to spin it all the way around, right? 180 degrees. So what this, you have to interpret this. This controls two things: the section orientation and the section offset. The section orientation is basically says we're going to do an orientation vector, and we're going to use the y-axis, and then this vector is going to tell it, basically telling it what direction to point the y in. Okay? So it decides however it's going to decide, that's the way it ends up. So based on the global coordinate system, so this y-axis that we have right here, this y-axis is the local coordinate for the cross section. So this specified vector is we're telling it what direction to point that y-axis in, using our global coordinate system. So in our global coordinate system, we want y to point in what direction? Oh, accidentally. What direction do we want the y to point in? Opposite. There is no opposite direction.
X.
I said in terms of global coordinate system. So the y and the z axis that it shows over here, this is the local coordinate system, right? This over here is my global, right?
So we want to be at the X side.
I want y to point in the x direction. Okay. So I'm going to come over here, and this is how I control it. I click here, and I can come down here, and I can tell it to point in the x direction. And it flips it around. Actually, I want y to point in minus y. I was just testing you.
was the Z, okay? Yeah, that's what it was. I thought it was the Z axis. Alright, everybody, everybody thoroughly confused now?
Yeah.
That's not, I don't know, maybe too much about it. Alright, let me fix it. So, we want the Y to point in the, you guys said minus Y, right? That's right. Alright. My bad. Don't raise your hand. Alright, so I hit OK, and now when I look down, they should at least be oriented correctly, right? Now, the only problem is over here is my neutral axis, right? The center of mass. I want this over here, right? So I need to basically move this cross section to the left so that it's right here. How much do I need to move it? Alright, there's an easy way to determine that. So I'm going to come over here. I'm going to go to edit. So this is where I did my cross sections, right? I'm going to click on this. I'm going to come over here and click on this. And all I'm doing is just trying to get over here to this menu. I'm over to this menu. Here's my C cross section. I'm going to click on that. I'm going to click the little wrench here, get edited. It brings it up. I'm going to do my preview. So this is what it looks like. So now I just need to come in. And right here is where that line, the blue line is, right? That's where it's currently at. I want it right here. So basically I have to take this and move it this distance from here to here, right? That's how much I need to move it to the left. How do I see what that distance is? I just need to come over here and click measure. I click on that, and notice it finds the point. It finds the point where the shear center is. I click on that, and now I'm going to come over here, and now I'm going to click on the point where the neutral axis is. And now it displays 16.7914. That's how much I need to move it. Alright, so I'm going to come over here and I can close this now. Okay, 16 point what? Alright, let me write that down. I hit cancel, I shut off the preview, I hit cancel, and close, cancel, cancel. I didn't change anything. Okay. Alright, so now I'm going to go ahead and slide everything over. So I'm going to go ahead and pick this one. I'm going to right click, I'm going to do edit mesh associated data. I go ahead and rotate it. And I'm on this one. So I'm ready to move it, and I basically want to move this to the left, right? Or along the minus Z direction by 16.7915.
1.4 minus
16.7914.
16.
What have you?
Went through you a negative 16?
Yes. Let me go faster. You go faster.
No, you're good. No, you're good. No, you're good.
Alright. So put a little minus there. What tells me that minus Z and not over here minus X? I can only change Y and Z. So that tells me that it's based off of the local coordinate system. Alright, so I go ahead and hit OK. And then it scoots across, and now when I look at it, this line is along the neutral axis. So now I just need to go to the other one, do the same, edit mesh associated data, come over here. And now if I come down here, that's exactly what I want to look like. Alright. Everybody good? Alright, so when I do my mesh collector here, I usually create all of the cross sections I have in my model.
Then once I create all of my cross sections, then I go in and start meshing. And then rotating things, however I need to do it. So, if you do it in pieces, I don't select everything and measure select everything and create all my elements at one time. I do it, I do all the vertical members, I make sure that's okay, then I go to the next one. If you do it all, then there's too many things to change at once. You lose track of what needs to be changed. It's too easy to mess up. Alright. Any questions? Very good. Alright, and then next time we'll talk about the share center and then next Wednesday we'll do share center and then I'll shut up and then you guys can work. Alright, so this right here is basically what it looks like. So we have a force of 300 pounds along this member right here, so it's 6 foot long. This one is going to be what? What cross section would we use for this one? Which cross section here, right? High, right? It says horizontal beam, angle beam. And then if you look down here, this looks like a nice little eye, and this looks like a T, right? Alright, so the thing when these two things meet right here, I want them to be at the center. Okay? So I want the center of this. Not the neutral axis, not the shear center, but the center of the vertical dimension. Okay? So this vertical dimension is what? What's the height? 1.5, right? So 0.75. That's going to line up with the center of this. At this point right here. Alright. So that's the little iffy thing that you got to draw. So you have to move things around a little bit to get it to line up. No problem putting the force here because we know that we need to use an even number of elements across here, right? The thing that's different right here is we have a force that's distributed. Okay? Sometimes we call this a line load, right? So this is 50 pounds per foot. So how many feet is that? 5 feet, so it's 250 pounds along that line, right? So you need to make sure you define that correctly. So we'll do it and look at it, study it a little bit. This is kind of interesting, right? What do we have going on here? A roller, right? So, but it's at an angle. So somehow we have to fix it so that it slides along this direction and it doesn't move up and move off the plane, right? Alright, so next time we'll learn how to create a coordinate system. And then we'll base the boundary conditions off of that coordinate system that we created. Okay? So we'll create a coordinate system and then we will define the boundary conditions based off that coordinate system. That's how we constrain it to move the way we want at that angle. Alright. So let's go ahead and close this. So that's where we're headed. Any questions? Everybody get the homework here? We just start moving pretty fast. We're moving slow, but once we go to the 3D stuff. Right. Good luck.